Quantum theories are now being integrated into research in the social sciences, and the reality quantum physics shows us has radical implications for research. This paper explores the implications quantum theory presents to research in the social sciences. When researching this topic, quantum physics was found to have a decolonizing effect and therefore presents challenges to traditional dominant Western ideologies embedded in research methodologies. For example, quantum theories complicate many aspects of the research process. Admittedly, most of them positivist ones, but I only have time to discuss researcher objectivity, reductionism, and mechanistic worldviews for you today. I started dabbling in quantum theory around 1997 before attending any higher education and began developing a unified field theory, which is my life's work. I decided I should go to university to learn how to properly develop this work. In university, not only did I develop a background in philosophy, but I also attained an honors degree in psychology where I specialized in consciousness studies and altered states of consciousness. Because I believed that a unified field theory should include all types of learning and unite them, which is essentially transdisciplinarity, I then decided to broaden my understanding and explore new areas of research. In a master's degree in gender studies, which was strictly qualitative, and another in social justice, which was mixed methods. My background thus has prepared me for mixed methods and transdisciplinarity, which ultimately led me to the Children and Youth PhD program. This paper incorporates all my transdisciplinary loves, but focuses mostly on linking quantum physics to consciousness studies, and presents new information, ideas, and evidence that could change how we view ourselves and humanity's position within the universe. This position is humbling and has the potential to diffuse power between the researcher and participants, which, in my case, would be children and youth. I understand that quantum physics is a new or inaccessible discipline for most, so I will do my best to present these ideas in a digestible manner. Please feel free to write down any questions as I go, and I will do my best to answer them. I will also provide my email address. In any case, this crash course in quantum physics will blow your minds. For this presentation, first I will discuss and define some theoretical frameworks such as contextualism, which I'll get to later, Pan-Experientialism, Panpsychism, Indigenous Knowledge Systems, and the many worlds interpretation of quantum physics. I will then discuss my methodology, which is transdisciplinarity. I then move on to how quantum physics complicates researcher objectivity, reductionism, and how it supports an indigenous worldview over a Western worldview to decolonize research. The ultimate goal is to paradigm shift from reductionistic and mechanistic understandings of the universe to an interconnected, dynamic, and organismic worldview that sees the universe as a living system or process. A pan-experientialist approach gives agency and subjectivity not only to objects and people, but also to cells, molecules, and subatomic particles. This stance believes human experience must have originated at the subatomic level, which implies not just humans, but individual cells, molecules, and subatomic particles have a capacity for feeling or a degree of subjective interiority. This presentation not only considers the subjectivity of cells, molecules, and subatomic particles, but also adds a conscious component to cells, molecules, and subatomic particles. The idea that consciousness permeates the universe is called panpsychism. If we can conceive of the universe as an interconnected, living, conscious agent, rather than seeing the universe as hierarchically arranged, then unequal power imbalances could be diffused. This can be extremely helpful when conducting research with children, because they can be seen as equal, conscious, co-collaborating agents in the research process. It was found that a pan-experientialist and a panpsychist approach can be used to resolve the measurement problem in quantum physics, also called the observer effect. which is essentially the finding that an observer can affect whether or not light will manifest as a wave or a particle during the double-slit light experiments. The measurement problem asks the question, how can one establish a correspondence between the quantum and material realms, or how can these realms interact or communicate? Since Pan-Experientialism believes cells and molecules to have agency and subjectivity, this opens up space for indigenous knowledges that adds a non-human animal and nature and plants, etc., to the complex, entangled universe. Thus, the beliefs of interconnectivity and reciprocity imply a reality that is relational, where all things are related. Indigenous understandings of the Earth as a living, interconnected organism can foster a paradigm shift to a new worldview or understanding of reality and decolonize research. Regarding the measurement problem, the observer can be any number of conscious elements, including the environment itself. Quantum research, therefore, does not only challenge dominant colonial frameworks, but also provides evidence for indigenous knowledges that have long understood the interconnectivity of the universe. The many worlds interpretation sees the process as the most real or best representation of reality, thus making the quantum and material realms more equal and involved in a conversation or dynamic process, as opposed to the traditional Copenhagen interpretation of quantum physics that leaves the observer out of the equation. This ends up supporting the false notion that the researcher can be objective. The classical Copenhagen interpretation of quantum physics keeps the observer in the material realm, as opposed to an entangled negotiator within quantum processes. The Copenhagen interpretation makes hierarchical ontological distinctions that places the physical world as more real than the quantum world. I argue in this presentation that there's no ontological distinction between the physical and quantum realms because they are interconnected, and the observer is a mediator between them. Moving to my methodology, transdisciplinarity as a methodological inquiry has been said to consist of four main aspects. 1. Inquiry-based rather than discipline-based. 2. Integrating rather than eliminating the inquirer from the inquiry. 3. Metaparadigmatic rather than intraparadigmatic. And 4. Applying systems and complex thought rather than reductive disjunctive thinking. Since my inquiry involves shifting from a reductionistic thinking to a complex systems thinking, transdisciplinarity is suitable for this ambitious journey. I use transdisciplinarity as a methodology by compiling research examples from many disciplines and using them as converging evidence. This produces a well-rounded case. Disciplines used here are quantum physics, psychology, sociology, consciousness studies, and indigenous knowledges. This presentation will have two modules. In Module 1, I will explore how quantum theories complicate researcher objectivity. Then in Module 2, I will falsify reductionism and show how indigenous knowledges challenge a mechanistic worldview. Quantum physics reveals an interconnected world and proves true researcher objectivity cannot occur. According to the many worlds interpretation, the process is considered most real because the outcome of this process determines which events, phenomena, and choice become manifest. Barad discusses the importance of dynamic processes in her concept of interaction. Interaction is the agentic process involving an entangled web of negotiations. She states that interaction signifies the mutual constitution of entangled agencies, which is in contrast to the usual interaction, which assumes there are separate individual agencies that precede their interaction. Within the interaction process, all things, humans, and objects are entangled and are active players in the meta-negotiation of agency and choice. This means that not only the researcher and the children participants are co-creators, but also the non-human elements or apparatuses used in the research process. Quantum understandings support Barad's interaction process by stating that at a specific time there is a unique arrangement of particles in the material realm where unique well-defined locations for macroscopic objects can be constructed out of the properties. This not only supports Barat's interaction, but also her position that objects are not prediscursive by nature and do not have fixed, stable descriptions or identities until all the actors involved choose a specific arrangement. For example, in one situation, one may use a saw to cut wood, and another use it as a musical instrument. In another example, in ancient wishhole shamanic tradition, there is a custom of using the hunting bow as a stringed instrument for casting a kind of spell to charm the intended prey. Even though these aren't perfect examples, they can help us understand how we can produce and reproduce matter, and how matter matters and is not passive in the interaction process. Taking this a step further, if objects are important negotiators in the interaction process, then children must also be important co-negotiators. What this means for research with children is that children should be treated as co-producers or as active meaning makers in research. This is important because dominant frameworks around children and youth see children as passive and not active agents in their environment. Rathelhuber states that agency can only exist in interconnectedness and be brought about in relations. Therefore, to begin comprehending children's agency, one needs to recognize its dynamism, which derives from its varied situatedness with relationships of power. Looking at interaction from the view of contextualism, elements are fluid, dynamic, and able to overlap. Contextualism suggests events or elements take their meaning from the contexts in which they are embedded. These contexts are not fixed, but are variable and subject to manipulation and reconstruction. Therefore, the borders and boundaries of the elements involved in the interaction process in reality are quite fuzzy. Adding quantum understandings to this, not only are the boundaries between people and objects blurred, but the boundary between microphysics and consciousness are also blurry. The observer therefore cannot be objective because no quantum phenomenon is phenomenon until it is recorded or observed. The observer's choice is important because quantum research describes the world as a probability distribution or a field of potentiality laying in wait for an observer's choice to determine what becomes manifest. So the world lies in potential representations of reality until we enact a choice, and when we do, the world collapses into one thing. The process where all possibilities lie await in potential is called quantum potential or structure process. This makes the observer's choice a powerful influence on what becomes manifest. If everything is interconnected and part of a dynamic process involving interlocking systems and forces, then a researcher cannot separate themselves from these connections to be fully objective. To help conceptualize how the self is interconnected within this entangled web of relations, I've developed a diagram showing how the observer mediates between the inner quantum influences and the contextual outer influences. This diagram could help answer the measurement problem question in quantum physics because it answers how the material and quantum realms can interact, communicate, or correspond. Another example of how the researcher or observer cannot be objective is through the delayed choice experiments, which are experiments testing the behavior of light. In this diagram, the self is represented as a prism, which mediates and separates white light into color. Light is an important feature in the visible world and is important to quantum theories, especially collapse theory, which is particle-wave dualism. But before I can explain the delayed choice experiments, I need to discuss the double slit experiments and particle-wave dualism. In the Young double slit experiments, slits are made in an apparatus intending to measure the behavior of light. When photons, which are particles of light, are directed through the apparatus, the behavior of light patterns makes can be seen on a detection screen behind. When the apparatus is static, the light patterns show a diffraction or interference pattern resembling ripples created by throwing stones into a pond. What is fascinating about diffraction is that superposition position occurs, where more than one thing occupies the same space. Remembering contextualism and how elements are fluid and able to overlap, these concepts could be a potential mechanism for how interconnectivity can take place. When the apparatus is on springs as the photons go through, light no longer behaves like a wave, but rather shows patterns of particle behavior. This is why Barad stresses the importance of objects in the interaction process, because the apparatus also has some power here to influence whether or not the light will manifest as a particle or a wave. During these experiments, it was discovered that both the momentum and the position of the particle cannot be known simultaneously. This is Heisenberg's uncertainty principle, which acts as a practical limitation on the possible precision of measurements. So depending on what's being measured, velocity or position, light can sometimes behave like a particle and sometimes behave like a wave. This is called particle-wave dualism, but I would rather call it particle-wave complementarity. During the double-slit light experiments, an observer can affect whether or not the light will behave like a particle or a wave, and that observer can make that decision even after the photon has made its way almost completely through the experiment, seemingly well past the point at which it would become either a particle or a wave, thus proving the photon's behavior is not predetermined, like how Barad's objects are not prediscursive. Bucks et al. Found that the more an observer watched, the more influence they had over what manifested. The measurement problem in quantum physics therefore complicates researcher objectivity because the observer can manipulate the outcome of these experiments and control whether or not light will become a particle or a wave. This shows that humans, including children, are co-producers of life. In the delayed choice experiments, light somehow knows it's being watched. How would light know when to behave like a particle and when to behave like a wave? How is this decision made in a split second more than halfway through the experiment? Between the particle and wave manifestations is the structure process or quantum potential Bohm describes as the mechanism that guides and organizes the energy. Like the interaction process, the observer can manipulate the structure process when the particles approach the slits and guide them into a particle or wave manifestation. Where the contradiction lies in explaining the delayed choice experiments is that the observer must be communicating at a rate either equal to or faster than the speed of light. This complicates special relativity because nothing can approach the speed of light. But is consciousness a thing? However, Pan-Experientialism may shed some light on this subject and explain the observer measurement problem. Earlier I explained how Pan-Experientialism gives agency and subjectivity to cells, molecules, and particles. If this is the case, then perhaps the observer's consciousness is capable of communicating directly with the light. William James proposes that consciousness does behave like light and can show properties of both particle and a wave. It is not hard to imagine consciousness as light because when analyzing MRI, CAT, or PET scan images, what is revealed are patterns of light. James discusses pure experience, which is phenomenological, and believes that we can interpret the presence of consciousness-like features on a quantum level in terms of Pan-Experientialism. This quote suggests we can interpret, understand, and interact with the quantum realm, and that we can communicate with light. This goes against Bohr's understanding of the knowability of the quantum world, as Bohr believed the quantum world could not be accessed directly, and its essence could not be known. Bohr's view reflects a traditional Copenhagen interpretation. Controversially, therefore, I suggest that consciousness can communicate with light. This communication is simultaneous and nonlinear, and therefore not subject to the laws dictated by special relativity. It also implies that we can know the quantum world directly. Simultaneous communication can be supported by observations of quantum entanglement, where quantum states of two or more objects have to be described with reference to each other, even though the individual objects may be spatially separated. In quantum entanglement, When one particle in the singlet state is measured, it has instantaneous effects on the other particle entangled with it. Here, quantum entanglement shows that instantaneous communication is possible. Einstein describes quantum entanglement as spooky action at a distance, and his explanation was that the particles must have decided ahead of time which action they're going to take so the other particle can act accordingly. Whether this suggestion is correct or not, you can see the video about that, it implies conscious particle agency like Pan-Experientialism and Panpsychism suggest. If we think of consciousness as a field that permeates the universe, it could be possible the field has properties that allow for instantaneous communication of conscious elements of beings across levels of reality, such as between the levels of physical and quantum realms. Therefore, the observer or researcher is not objective, but entangled within different levels or fields of varying degrees of consciousness. To incorporate quantum understandings into research, the role of the researcher, the processes behind the phenomena, and the context are important. When conducting research in the social sciences, we must acknowledge the self as an interconnected participant within a process, not an objective observer. Barad says that the world is in a state of becoming, or an ongoing open process, and things are not things in themselves, or independent, stand-alone objects. The idea that humans are interconnected with the universe and are not objective observers may be a new concept for positivist research in the social sciences, but is not new to indigenous beliefs that have long understood the world to be cyclical, reciprocal, relational, and interconnected. Let's just take a couple moments to let that all sink in, shall we? Before we move on to Module 2. Indigenous paradigm comes from the fundamental belief that knowledge is relational. For example, the Maori people of New Zealand's worldview is based on the principle of Wikipapa, which turns the universe into a moral space where all things great and small are interconnected, including science and research. Similarly, the Mi'kmaq teachings are based on the interconnectedness of all things. These understandings see human beings as interconnected with living and non-living and immersed in many relations and connections. Indigenous knowledges therefore have interesting implications for the measurement problem, because if there are no humans observing phenomena, any number of conscious elements such as non-human animals and plants can be considered an observer, even the environment itself. Therefore, the environment as a personified observer can explain quantum contradictions of how elements remain intact and manifest even when we humans are not observing. According to indigenous understandings, the relationship of the human to the environment and other animals and plants, etc., is reciprocal. Sylvia Moore discusses how we are a part of the circle of life and connected to the trees, the water, and even the salmon. What's important to note about her book is that it was the process that was important. It was the process that determined the success of the respawning of the salmon in the stream. According to indigenous understandings, there is no separation between humans, other animals, or the environment. But if there were distinctions made, then they are an I-we distinction, not an I-you distinction. These distinctions represent the difference in worldviews between indigenous peoples and Western dominant society. This brings us to the difference between organismic and mechanistic worldviews. One's worldview is one's philosophy of life, and one's worldview can influence one's research and can skew findings at every stage in the research process. The two major worldviews discussed here are that of the mechanistic worldview and the organismic worldview. An organismic thinking, also called organistic or organicism or systems thinking, sees the world in terms of complex patterns with an implicit order for unification. An organismic worldview, however, goes against traditional positivist understandings of reductionism that tend to produce a mechanistic worldview. A mechanistic worldview thus focuses on linear relationships and individual elements or parts. In this worldview, the sum of the parts is assumed to equal the whole. This is called reductionism, which is the theory that every complex phenomenon, especially in biology or psychology, can be explained by analyzing the simplest, most basic physical mechanisms, or the practice of simplifying a complex idea, issue, condition, or the like, especially to the point of minimizing, obscuring, and distorting it. In order to present a strong case for the shift to an organismic worldview versus a mechanistic worldview, reductionism needs to be falsified. Reductionism can be falsified in several ways. One example is through general systems theory, which is when the various branches of science grew so far apart in their specialties that they could no longer communicate. The only way the different branches of science could communicate was to develop a theory they could all agree on. The scientists eventually agreed that there was such a thing as a system, and proceeded to create two hypothetical systems as starting points on a continuum. On one end is a purely open system, and on the other hand is a purely closed system. These are hypothetical because they cannot exist in the physical universe. For example, every part in the purely open system communicates equally at the same time and intensity, which would end up crashing the system. In a purely closed system, none of the parts communicate. This is also not physically possible. However, in a hypothetical, purely closed system, reductionism is technically possible. Only in a purely closed system can the sum of the parts equal the whole, because there's no novel or new information being created, because there's no communication whatsoever between the parts. General systems theory can, therefore, be used as evidence against reductionism, because reductionism can only happen in a hypothetical situation. Reductionism is important to falsify because it can lead to the objectification of the earth and seeing the earth as a machine with a bunch of parts, thus turning a dynamic, living organism or process into a static, lifeless machine. The world is not a bunch of parts for human consumption. It could be argued that the objectification and dehumanization produced from a mechanistic worldview is more likely to lead to the justification for the destruction of the planet and justifies inequalities among people. Having an organismic worldview that aligns closely with actual research in quantum physics makes way more sense than a mechanistic worldview based on a false premise. A mechanistic worldview produces a short-sighted understanding of complex systems. If we could see the universe as interconnected, then we might be more likely to see the earth, other animals, plants, and children as living, dynamic, co-producers of life and research, not static, prediscursive, fixed elements for our manipulation. An organismic, interconnected worldview is therefore more likely to diffuse power relations in research setting and promote equity among everyone involved. Quantum theories confuse reductionistic, simple, fixed categories because realistic quantum systems are never isolated but are immersed in the surrounding environment and interact continuously with it. According to string theory, thinking of physics in terms of elementary building blocks appears to be wrong, or at least of a limited reach. We can no longer distinguish the individual particles. Instead, they dissolve into an intertangled mesh of energy like an ingredient of a cake in a hot oven. This is closely aligned with transdisciplinarity because we cannot reverse engineer the cake, and the cake is indistinguishable and different from the ingredients or the disciplines involved. We cannot separate out the eggs from the flour and the sugar and say that the sum of the parts equal the whole. Also, we cannot say just the eggs caused the cake because none of the ingredients caused the cake. The person making it did, and there were non-human elements involved such as mixers, spoons, measuring cups, etc. We also cannot say the eggs are superior to the flour and the sugar. Therefore, when one is conducting research in the social sciences, a researcher must acknowledge complex dynamic systems, and to reduce a system to its parts and fixate static labels onto a person or a phenomenon is to distort reality into something it is not. In conclusion, quantum theories and indigenous understandings of interconnectivity have important implications for research in the social sciences by complicating researcher objectivity, reductionism, and a mechanistic worldview, at the same time providing evidence for a more complex, contextual, dynamic, relational process where all non-living and living things, including children, are co-negotiators in the interaction and research process. Welcome to the interconnected mess of all things. Thank you. My name is Sandra Croker.